Okay, in this video, we are going to solve the sum and difference formulas, trig identity problems here. So we're going to suppose that our sine alpha is 12 over 13 for a quad 2 angle theta, and sine B is equal to 3 over 5 for a quad 1 angle beta. We're going to find exact values for the following: cosine alpha, cosine beta there, looks like it got erased a little bit, and cosine alpha plus beta, and then we're going to find sine alpha plus beta, which is a little bit further down because we need some room for C there, and B, and D, I'm sorry. Okay, so first I want to find cosine alpha and cosine beta by using the information they gave us about the sine. So to find cosine alpha, I know I'm just going to make a little graph right here. I know that cosine alpha, the alphas are in quadrant 2 because it tells us up in the problem here, quadrant 2 for sine alpha. So that's how we find cosine alpha. So that's over here in quadrant 2. So remember, there's an acronym that says all science teachers are crazy. And so all stands for quadrant 1. That means everything is positive. Number 2, science, S. S stands for sine. That means the sign is positive. Okay, so that means cosine and tangent are both negative. We don't care about tangent in this problem. We're just going to focus on cosine. So my cosine will be negative here. So let's go ahead and figure out what it would be. I'm going to go ahead and make a little triangle there. And we know that sine of alpha, so this is my alpha right there, my little angle, 12 over 13. So sine, remember this from SOHCAHTOA, from our other videos and our other assignments. Sine is opposite over hypotenuse. So opposite here from the angle would be this 12. The hypotenuse is always this longer angle, or side, I'm sorry, the longest side, which is 13. This is a very famous Pythagorean triple. And that means my other side will be negative 5. Okay, it's negative because we're in quadrant 2. That's the only reason why it's negative. Otherwise, it would be positive. So a 5, 12, 13 is a very famous Pythagorean triples, which we have seen in the past assignments. So for my cosine alpha, it is now going to be the adjacent over hypotenuse. So this is going to equal negative 5 over 13. So we're going to go ahead and box that since that is our answer. All right, we're going to then go ahead to cosine beta. This is going to be over in quadrant 1. So we're going to make another little triangle over here. And in this one here, we're going to have our cosine beta. My angle beta is going to be right here, and opposite is 3, since that's my sine over hypotenuse, which is 5. So sine beta is 3/5, known from given in the equation. So we're going to find cosine. Cosine is adjacent over hypotenuse. Again, the 3 and the 5 are part of a Pythagorean triple that I have tables throughout a couple of different modules. So this right here is going to be a 4. And these are all in quadrant 1, everything positive in quadrant 1. So cosine is adjacent over hypotenuse. So this will be 4 over 5. Okay, so we got A and B. Now we're going to go ahead and bring in, that is stuff that we've seen before, so hopefully that wasn't too challenging. Now we're going to look at the sum and difference equation here. So for cosine alpha plus beta, this is going to be equal to, from our formulas, cosine alpha cosine beta minus sine alpha times sine beta. Okay, and then we're just going to take each of our numbers and plug them in to the certain spots. Just be very careful that you don't mix up the alphas and the betas and the sines and the cosines, okay? Because they all sound a little similar there. So cosine alpha from A is -5/13. And then for cosine B, this is going to be 4/5. Minus, remember sine alpha, that is a given from right up here. This is 12/13. And then my sine beta is from also a given, 3/5. And now we just have to do the math on it. In other words, multiply this out. So this is going to be -20/65 minus 36/65. And then we're just going to go ahead there, minus, minus. So this is -56/65. That is our answer right there. All right, last one. We're going to go to D. And this is going to be sine alpha plus beta. This is equal to, from our sum and difference formulas, this is sine alpha times cosine beta plus cosine alpha times sine beta. So see, very subtle differences here from each term, but be very careful on what we plug in here, okay? So sine alpha, if you need to go back up here, is the 12/13. Just substitute for everything here. So sine alpha was 12/13. My cosine beta is this one here, 4/5. Plus my cosine alpha was the -5/13. And then my sine beta was the 3/5. Okay, and I got those from up above. I was getting busy moving back and forth, so I'm not going to do it again. So now we just do the math here. So 12 times 4 is 48, 13 times 5 is 65, plus -5 times 3 is 15, and 13 times 5 is 65. And then 48 minus 15 is, what is that, 33/65. Bam. And we're done. So that is the sum and difference formula. And like I said before, make sure you have all of those that from the module from up above this video. You will see all of those identities there. And I highly recommend you writing them down so that when you're doing your assignments, you have them very close by. Okay, guys, I will see you in the next video.